Okay, so in this video, we're going to talk about applying mixed transformations. So what does that mean? That just means we have multiple things that are going on. Okay, so for this one, we have a mixed transformation. We have two transformations going on. So this is an absolute value function. Well, if the absolute value function is y equals the absolute value of x, oh, what happened here? Oh, let me scroll up some. Okay, so if the function is y equals the absolute value of x, then we know that this negative and this 3 are not supposed to be in the parent function. So what's going to happen is, these two values are going to do something. Well, we learn that a negative applied directly to x will reflect the function about the y-axis. Okay, so it's going to flip over the y-axis. And then the 3, we learn that, right, because it's applied to x, instead of expanding the function, it's going to shrink the function. So it's going to shrink by a factor of 3. Okay, so what will that look like? Well, the reflection, let's draw the parent function first. So the parent function is absolute value, 1 to 1. We know that already. Yep. That wasn't 1 to 1, this is 1 to 1. Get my points a little straighter. All right, so the parent function looks like this. Okay, so this is y equals the absolute value of x. Well, we know that whatever the x values are, right, if they're 1, it's now going to be -1. If it's 2, it's now going to be -2, right? And then the same thing, if it's -1, it's now going to be 1. So let me change the color on that. And if it's 2, it's -2, it's now going to be 2, right? So these values went here, and the orange values basically went there and reflected it about the y-axis. So remember that our y-axis is this vertical axis. So it should look symmetrical. So if we draw it, it looks something like that. But what else is going to happen is that there's going to be a second transformation. So the second transformation is going to shift the x values, right? So if x, I'm going to do that one in, let's say, red. So if, let's try blue. Okay, so if x was 1, right, remember that 3 over 1, if you flip it, that means you're going to basically take x and shrink it by 1/3. So x is now going to be 1/3. So let's graph it the best we can. So it's there. And then if it's -1, it's going to be -1/3. And then if it's 2, right, it's going to be 2/3, which is like 0.6 or something like that. So that one will be a little further out. And it's difficult to graph those, but let's do 3, right? So if x was 3, it's now going to be 1. So it looks like that. So that's kind of a reference to about where our point should be. Those are a little more difficult to graph. And if it was -3 here, right, now this point is going to go to become 1. Okay, so we're going to get an absolute value function that's been, we already did the reflection, and we know that that's going to look the same, but you still have to note what happens to it. Okay, so basically it's going to be squished in, right, because it's here and it's going to be reflected about the y. So basically it turned around and then it was squished in. Okay, so imagine someone turning you around 180 degrees and then pushing your arms in or something like that if you had your arms up. All right, so now let's go to the quadratic and see what's going to happen with that one. So we have, we know that this one is y equals x squared for the parent function. So let me go back to gray. So my parent function, I know those values. I should have them committed to memory by now. It's best if you do, so that you don't have to waste time trying to figure out what the parent function looks like. You should be able to draw it right then. And for most of the cases, we're using the same values from -2 to 2. Okay, so now we have that negative. So we know that those points are going to be reflected again, right? Those points are going to go here. These points are going to go to this side. Same thing is going to happen here and here, right? They're going to do an exchange. So they're just going to flip around. And so that's that one. And so for this one, I'm not going to like graph it fully. I'm just showing the outline that there is another function on top of there. And then now what we're going to do is, since our values in this case are 1/3, right, that means it's going to stretch horizontally, okay, by a factor of 3, right? Because if we take 1/3 and flip it, do the opposite, it's going to be 3 over 1. So all of our x values are going to be multiplied all of our x values are going to be multiplied by 3. So if x was 1, right, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so if you need to look at what's happening to x at that time. So if x was 1, now it's going to be 3. If x was 2, now it's going to be 6. If x is not, is 3, sorry, now it's going to be 9. Okay, so do we see what's happening there? If x was negative 1, now it's going to be negative 3. If x was negative 2, right, now it's going to be negative 6. And if x is negative 3, now it's going to be negative 9. So what we get is a big fat bowl, right? We get a big fat bowl that looks like that. Okay, so we get a parabola that looks like that. All right, now let's see what happens with the exponential function. Okay, so y is equal to 2 raised to the power of x, because that's our base. So the only thing that we need from this function is our base and our exponent in order to know what the parent function is. So you ignore the negative and the 1/2 for the parent function. And so we know that this one is exponential. Okay, so the things that don't go there are the negative 1/2. So we have a negative sign, which is going to reflect it. And we're talking about it's being applied to x. So we learned up here that a negative applied directly to x will reflect it over the y-axis, right? And then we learned that 1/2 applied directly to x will, well, over here, what did 1/3 do? It stretched it horizontally. So that's going to stretch horizontally. Okay, that's going to stretch it horizontally. So let's graph the parent function so that we can see what it looks like. So I'm going to graph that one in gray. So the parent function for 2 to the x is, it's what, negative 2 gives me 1/4. 2 to the negative 1 gives me 1/2. 2 to the 0 gives me 1. 2 to the 1 gives me 2. And 2 to the second power gives me 4. So here's my parent function here. All right, so it looks like this. So y equals 2 to the x. Okay, so now let's figure out what my transformations are going to be. Well, in this case, this one is not symmetrical. So all of this right here is actually going to come over here. So this point is going to be just on the opposite side at 1/2. This point, negative 2, will be on the opposite side at negative 1/4. And this point will actually come over here. So this will go here, and this will actually go on this side. So this will be at 1. And this is just at first. This is an intermediate transformation. We'll have to do the second one next because I don't want to confuse you. Okay, and then, so this is intermediate. This is the reflection part, right? So we learned about the reflection. And now what we're going to do is we have to, and this was 2, so that should be there. All right. So there we go. Okay, so now what we have to do is we actually have to stretch it by half. So now what we're going to do, we know that we had, after our reflection, we had a value here, we had a value here, we had a new value here, we had a value here, and then we had 0. Okay, so now what's going to happen is going to be pulled in both directions horizontally. So all your x values are going to stretch by what? That's right, you guessed it. So the reciprocal will be 2 over 1. So all of your x values are going to multiply by 2. So I'm going to do that second step. I'm going to do that one in blue. All right. So to finish this transformation, if we look at our x values, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So if x was 1, now it's going to be what? 2. If x was 2, now it's going to be what? 4, right? And then on the other side, right, 0 stays the same. If x was negative 1, it's now going to be 2. If x was negative 2, it's now going to be negative 4. So that's that horizontal stretch that we were talking about. All right, so now let's plot all these points. All right, and we can see that it's stretched, and then this one is actually, it kind of stretches up a little bit, but it's still approaching 0. All right, so everything just kind of swaps places, and it's hard to see that unless you can like show great detail, but the more I zoom in, the more the ink is going to get blurry. So basically we can see that the function was flipped about the around the y-axis, and then it was pulled, right, horizontally in both directions. All right, So I hope this video has helped you with applying multiple transformations. And so you can use this and look back at it as you need to finish your homework, and hopefully you get better at making these predictions, all right? And watch this video as many times as you need to until you get this. All righty, see you next time. Hope you're ready for your concept check.